But do write down these equations, think about what they mean, and the equation for correlation here, which includes, you'll notice, covariance in it. So definitely pause this video, write down these equations if you don't have them already in front of you. And we're going to do an example now showing these. So in this example, let me bring it up here. We are going to be looking at a company's monthly sales figures as compared to their marketing spend. So every year, every month they're spending a certain amount on marketing, and then they are recording their sales figures for that month, and they want to know, what's the relationship between the amount we spend on marketing and our monthly sales. You'll notice on this spreadsheet that I've kept the equation, my favorite equation for covariance, though you can use either one, and the equation for correlation here. And we're going to manually calculate the covariance and correlation, and then I'm going to show you how to do it using Excel's handy shortcuts. But first off, let's do a little sanity check here, just sort of quickly make some predictions. Based on common sense, we would expect there to be a positive relationship, right? Like the more you spend on sales, the more you spend on marketing, the more sales you're going to generate. Hopefully that's the case. I did a scatter plot of this data, and down here on the x-axis we have the marketing spend, on the y-axis we have the monthly sales, and I drew a best fit line. I didn't draw, Excel put a best fit line through this data, and you can see that there is it's pretty linear. It looks pretty good. This line is going to be a fairly excellent predictor. So what does that tell you about what we would expect the correlation to be? Well, first off, we expect it to be positive. And looking at this, I would expect it to be pretty close to 1. This is not a great big cloud of points. This is actually points that almost line up. So the closer they are to linear, to an exactly linear relationship, the closer the correlation is going to be to 1. So we are expecting this to be a positive correlation that is pretty close to 1. All right. So let's start out by calculating the covariance, which we're going to have to do since covariance is in our equation for correlation. I'm going to start off, we need the expected value of x times y. And so what is the expected value? It's the average. That's all it is. Finding out, and sometimes it's a weighted average, but really the expected value is just an average. So let's keep everything in line here. I'm going to write x times y. This is going to help us get the average here. So first off, I'm going to set this up so we're calculating each of these values. Let's set this up so that that border doesn't disappear every time. And I need an average here. So I'm going to go in here and write average, and I'll get to that in a moment. Average of B2 to B13. Okay, so this is my expected value of x times y, monthly spend times monthly sales, right? That's the first part of my equation. It's just the average of each of the multiplication of those two data points. That's it, the values that are associated with each of the data points. But now I actually need the averages of x, and I need the average of y as well, so we'll just drag this over. So far, so good. And so now I should be able to figure out my covariance. So go down here, write covariance. And this is going to be equal to my expected value of x times y minus the average for my marketing spend times the average for my monthly sales. That's my covariance. Now we need to figure out what the correlation is going to be. Okay, but for correlation, we're actually going to need standard deviations. So let's figure out what those are going to be. Wait a second, is that, yeah. Oh, I forgot to label this. STD, standard deviation. and we'll just drag this across. So now I have my standard deviation for marketing and monthly sales. My correlation is going to be my covariance divided by standard deviation of x times standard deviation of y. And let's reduce some of these decimal points. And correlation to 0.95, 0.952 if you want to get closer. So does that match what our predictions were? Yeah, absolutely. We were predicting something, a positive association that was close to 1. We're looking good. Now, let me just show you the quick shortcut using Excel functions, which you probably already knew about. We're going to just use covariance here. It wants the first array, which is going to be the covariance between these two variables. I'm just going to go ahead and grab these. Exact same number. Everything's checking out. Do the same thing with the choral function. Lovely. It all works out. So that is an example of using Excel. I mean, you could do this by hand if you had to, and using these equations to calculate covariance and correlation.